Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this video lecture, I am going to explain you about the surface measurement, that is by direct methods. So we have four different direct methods. So I am going to explain these direct methods in today's class. This is my 27th lecture regarding to the subject metrology. So in the last class, we have discussed about the numerical methods of the surface finish. That is the center line average method, root means square method, and the 10-point height method. In today's class, we are going to see the measurement of surface finish through direct contact. That is the contact type, that is the direct contact. So in the first one is the Stylus Probe type. So in this Stylus Probe, this is the contact based type. So it is directly going to contact with the surface finish. So it has the stylus which is in the direct contact with the surface, and it has a skid which is the main part and then pick up. So these methods enable to determine a numerical value of the surface finish of any surface. So whenever you are going to determine the numerical value or you are going to measure the surface, you are going to find these methods for the direct contact type. And in that measurement of surface finish in the stylus probe type, this skid or shoe which is drawn slowly, so these are going to move slowly over the surface. Either we can use our hand or by motor drive. So this is slowly moving over the surface and the skid when moved over the surface follows its general contours. So whenever the skid is moving in the direction of the surface roughness, that is the flatness of the surface, it is going to get some contours. So that is following its general contours, and it provides a datum for the measurements. So datum means a division of points which gives you a data from the stylus point. So these are obtained by from the stylus point only. So a stylus or probe which moves over the surface with the skid. So this stylus is attached to the surface of the skid. So the probe is attached directly to the skid, and the stylus should be cone shaped with a spherical tip. So the stylus consists of a cone shaped tip, that is the spherical tip, like as the ballpoint one. So whenever you see the ballpoint ending, it has a spherical tip. Likewise, the stylus also gets the same spherical tip, which is going to measure the surface flatness smoothly. This records the microgeometrical form of the surface. So whenever the stylus is going to touch the surface, that records the microgeometrical forms of the surface, that is the curves of the surface. So whenever we are going to see the microgeometrical errors, so that is of this type. So these kind of errors is called as microgeometrical forms. Whenever it comes to macrogeometrical forms, it is of a big wave. So these big waves forms the macrogeometrical error. But in the microgeometrical error, the waves are in the form of this small size only. So that is meant by the microgeometrical forms of the surface, and it moves vertically up and down related to the skid movement. So whenever it is getting a roughness, it is going to move up and down, which is related to the skid movement due to the roughness of the surface. So due to the roughness of the surface, it is going to move up and down. As the stylus tracks the surface peaks and valleys. So whenever this stylus is going to trace the elements in the surface roughness, we got the surface peaks and valleys. So peaks means the highest point of the peaks, valleys means the depth point. So that is the lowest point of the roughness. Its vertical motion is converted to a time varying electrical signal that represents the surface profile. So whenever we are getting these microgeometrical forms in the vertical form, it is converted to a time varying electrical signal. So that is converting it into a digital form and to represent the surface profile. So the form of the surface profile is provided in that electrical signal. So generally, it is desired that if the skid is moving up, then the stylus must also be moving up. So generally, this skid is attached to the stylus. So whenever the skid is moving on the upward portion, the stylus must also be moving in the upward motion. So that is the general movement regarding to the stylus surface. So this is the skid and this is the stylus which is attached to the form of the skid as a support base, and this is in the transverse direction, that is the x direction, but the stylus moves the z direction only. So this is the surface roughness values of the skid. So this is the drive unit, and this drive unit is attached to a hinge in which the skid is attached to the hinge and a stylus is attached to the skid. So this is the surface being measured, and whenever you are going to attach the stylus to this surface roughness, so the stylus moves in the upward and downward direction, and these errors of these forms are sent to the traced forms are sent to the drive unit to form to the digital circuit one. So, and whenever the deflections is sent to the drive unit by the stylus in the form of microgeometrical errors, the drive unit sends it to the reference number. So, the drive unit sends a reference number according to the values sent to the or errors sent to the drive unit by the stylus, and then it is evaluated as a reference number. So the geometrical errors, that is the micro geometrical errors, are in this form. So this is the form of the micro geometrical errors. So there we can set the measurement of these surface finish errors to the drive unit, in which it can send by the stylus. So this is the first one. So first type of the surface measurement. Next one is the profileometer. Second type of this measuring instrument is the profileometer. So it is indicating and the recording instrument used to measure roughness in the microns size. So these profilometer of the contact tile is used to indicate and record the instrument which is used to measure roughness in the microns. Whenever we are going to see it in the micron size, we are going to measure the roughness. And these profilometers consists of two units, that is the tracer and the amplifier. So in first it gets the tracer, which is going to trace the surface with the stylus or probe which is attached to the induction coil, and then it gets the amplifier. So this amplifier is going to transfer the errors into a coding generator. So you can see it in the picture also. So this is the profilometer and this is the surface to be tested, and it gets the stylus or probe. So which is the longest form. This is the stylus, and it gets the spring attachments attached to the induction coil. So these are the spring attachments which is used to move up and downwards in smooth form. And this is the induction coil. So this is the induction coil which is attached to the stylus or probe. Whenever the stylus gets a roughness in the surface, so it is moved to the upward motion. So it is moving in the upward motion, and it is generated through the stylus, and the stylus moves in the upward motion through the magnet which is attached to the induction coil. So here the waves can be generated into the magnetic form into the induction coil. So this is moved by the pickup unit. So these are all the pickup unit, and it is sent to the amplifier unit. So then it is directly sent to the amplifier unit. So firstly, tracer is finely pointed stylus mounted in the pickup unit. So this tracer is the finely pointed stylus. So stylus which is in the form of spherical shape at the end, like a ballpoint pen or a ball bearing. So whenever we see a ball bearing, it is touching only one point of contact to the surface. So therefore, in this type of stylus also it is attached to the one type of contact, that is the ball type. So this tracer is finely pointed stylus mounted in the pickup unit, which consists of the induction coil located in the field of permanent magnet. So this is the induction coil which is attached to the permanent magnet. So that is the permanent magnet attached to the magnetic field of the induction coil. So here we can get the magnetic field impact for the induction coil, and when this stylus is moved across the surface to be tested. So whenever it is usually going to move it on the upward direction. So whenever it is to be tested, it is displaced vertically up and down due to surface irregularities. So whenever the surface gets irregularities, so this pointer is moved in the up and down direction. That is moved in the up and down direction due to the surface irregularities. And this causes the induction coil to move in the field of permanent magnet and induces the voltage. So whenever this stylus is going to move in the upward and backward downward direction, it is attached to the induction coil. So therefore it is attached to the induction coil in the field of permanent magnet. So in which it has a magnetic field to the field permanent magnet, and this magnet induces the voltage. So then wherever it gets the magnet, it gets the voltage. It induces the voltage, and the induced voltage is amplified and recorded. So this induced voltage is amplified and recorded in the pickup unit. So that is the working of the profileometer gauge. And next one, third type of measuring instrument is the Tomlinson surface meter. So this is an important one, Tomlinson surface meter. So first of all, we are going to take the principle, that is the draw the principle from the Tomlinson surface meter. So this instrument uses the mechanical cum optical means for fabrication and magnification. So this instrument is used based upon the mechanical parts and the optical parts, which is used for the magnification of the meter. So that is magnification of the instrument. So it is used for the magnification of the instrument, and this is the Tomlinson surface meter. So this Tomlinson surface meter gets a stylus. So this is the stylus in which it gets a form of the pencil. So pencil long. So this is called the stylus, in which it gets a diamond probe to its lower end. So general in the profileometer it gets a spherical type to the stylus probe, and in the stylus probe also we get the spherical type of end, but in the Tomlinson surface meter it gets a diamond probe attached to it, and to the downward of it it gets a skid which is moved on the or oscillating direction, and in the below that we get the workpiece, And to the stylus it gets a fixed rollers and the lapped steel cylinder. So this green color circle is called the lapped steel cylinders, and this is the top view of the lapped steel cylinders, and this is the front view of it. And it gets a fixed rollers attached to the lapped steel cylinder and an arm which consists of the diamond scriber which is attached to the smoked glass. So this smoked glass is printed by the engraved through the diamond scriber which is attached to it. Whenever the arm is used to move, the body also move. And to the stylus at the first point, that is the topmost point, it is attached to a spring to the horizontal motion of the body. So whenever there is a deflection, it is used to move to the spring which is attached to the horizontal motion of the body. So whenever these diamond's probe contained stylus is got irregularities in the surface, it is moved in the upward direction. Then by moving the surface to the upward direction, the lapped steel cylinder attached to the surface of the stylus is moved in the clockwise direction. So by moving it in the clockwise and anti-clockwise direction to the lapped steel cylinder and the fixed rollers. So the fixed rollers is moved to the arm, and the arm is moved in the the arm is oscillated through the upward and downward direction like the meter. So the end of the arm is connected to a diamond scriber which is engraved the curves in the smoked glass. So that is whenever you get the displacement, the spring is moved to the horizontal motion of the body and it is moved in the forward motion, and the smoked glass is engraved by the diamond scriber in which you got the irregularities through the detecting stylus. So we go to the construction now. So in this, it got the diamond stylus on the surface finish recorder in which it is held by the spring pressure against the surface of a lapped cylinder. So it got a lapped cylinder to the diamond stylus point. The lapped cylinder is supported one side by the probe and the other side by the rollers. So this lapped cylinder is supported by the one side by the probe and other side by the rollers, that is the fixed rollers attached to it. And the stylus is also attached to the body of the instrument by a leaf spring. So this is the leaf spring in which it is used as the connection between the body and the stylus. And its height is adjustable to enable the diamond probe to be positioned, and the light spring steel arm is attached to the lapped cylinder. So these lapped cylinder is attached to stylus by the diamond probe positioning and the light spring steel arm, that is the lapped steel cylinder. And the spring arm has a diamond scriber at the end, and the smoked glass is the rest on the arm. So the spring arm has a diamond scriber. So this is the spring arm which is attached to the lapped steel cylinder. So this is attached to the lapped steel cylinder, and at the end of it, the diamond scriber at the end, it got the smoked glass which is rested on the arm. So the diamond probe is attached to the arm. Next, the diamond stylus on the surface finish recorder is held by a spring pressure against the surface of a lapped steel cylinder. So this is attached to the lapped steel cylinder, in which it gets the spring pressure against the surface of the lapped steel cylinder. And the diamond stylus is the surface finish recorder here. The stylus is also attached to the body of the instrument by a leaf spring, and its height is adjustable to enable the diamond to be positioned conveniently. So the stylus is also attached to the body of the instrument by a leaf spring. So its height is then adjustable to enable the diamond to be positioned conveniently. So this is to be adjusted to be positioned conveniently to the height of the leaf spring. Next, the lapped cylinder is supported on one side by the stylus, and on the other side, the two fixed rollers are shown in the figure. So the lapped cylinder is supported one side by the stylus and the other side by the two fixed rollers. And this stylus is restrained from all the motions except the vertical one by the tensions in coil and the leaf spring. So this is restrained from all the motions except the vertical one by the tensions in the coil and the leaf spring. The tensile forces in these two springs also keep the lapped steel cylinder in position between the stylus and a pair of fixed rollers. So these are attached to the pair of fixed rollers, in which it gets these two springs. So these two springs is attached to the lapped steel cylinder in position between the stylus and a pair of fixed rollers. So the lapped cylinder is fixed to the pair of fixed rollers, and a light spring steel arm is attached to the horizontal lap steel cylinder, which it carries at its tip a diamond striker which gets against the smoked glass. So whenever these fixed rollers is moved, the arm also moves in the forward and backward direction, that is in the upward and downward direction, which moves the smoked glass and the diamond striker engraved on it. సో మనకి ఎప్పుడైతే ఈ స్మోక్డ్ గ్లాస్ అనేది ఫార్వర్డ్ మూమెంట్ లో వస్తుందో అప్పుడు డైమండ్ స్ట్రైపర్ అనేది మూవ్ అవుతూ దాని మీద ఈ ఇర్రెగ్యులారిటీస్ అనేవి డ్రా చేస్తుంది అనమాట. దట్ ఈస్ త్రూ ది irregularities drawn on it. And next we go to see the working of this Tomlinson surface meter. So when measuring the surface finish, the body of the instrument moves across the surface by a screw rotation. So this is the screw attached to it, that is the lapped steel cylinder, in which it gets the fixed rollers which moves the arm to the upward and downward direction. So this is called as the screw rotation. So the screw rotation is towards the fixed and upward and downward direction. Next, the vertical movement of the probe caused by the surface irregularities makes the horizontal lapped cylinder to roll. So the irregularities occurred in these surface irregularities. So this is the workpiece to be tested, and whenever the diamond probe consists is to be tested the surface, whenever the surface got the irregularities, the diamond probe moves the stylus on the upward direction, moves the upward and backward direction. So this is the direction symbol, and this moves the horizontal lapped cylinder to roll. So that is on the rolling, that is clockwise and the anti-clockwise direction, which is going to roll. Next, this rolling of lapped cylinder causes the movement of the arm. So whenever this stylus moves the lapped cylinder, lapped steel cylinder to the lapped cylinder is used to move the arm. So this movement causes the movement of the arm. This is the movement. So this movement induces the diamond scriber on the smoked glass. So this moves the diamond scriber which is attached to the smoked glass and its movement. And then finally, the movement of the scriber together with the horizontal movement produces a trace on the smoked glass plate. So this is the tracings of the diamond probe in the smoked glass, and this trace is magnified by an optical projector. So this is to be measured by the optical projector. So this is the working of the Tomlinson surface meter. So look the arrangement for a while. Next one is the Taylor Hopson Calixer. So this Taylor Hopson Calixer instrument also gives the same information as the previous instrument, but much more rapidly and accurately. So this is by using the electrical parts. So we are getting the accurate measurement and the more rapid measurement. So here you can see the parts here. So I will going to explain the parts. So first one is the oscillator, in which it consists of a Wheatstone bridge. So you all know about the Wheatstone bridge, in which it consists of 4 points. The points AD is attached to the amplifier, and the amplifier is then connected to the demodulator. And the demodulator has the two ends, that is the filter and the recorder. So in the filter it gets a meter, and the recorder it gets the final end of the position. So whenever this skid has the armature stylus, so this is the armature stylus which is attached to the skid to define the irregularities. So to measure the irregularities through the armature, and it got the attachment to the skid, and this is the Wheatstone bridge. So this is the Wheatstone bridge in which it got the 4 point, that is AB and AC. So these are the ends. This is the D position. So this E-shaped stamping and this skid armature is all in the Wheatstone bridge. One, this is the top view and this is the front view. So whenever the stylus causes the irregularities, you see it is then sent to the oscillator through the western bridge. So it gets the carriers like this. So these microgeometrical forms of errors are in the form of carriers. So these carriers are like these. So the longest forms of the peak and valleys. So then it is sent to the amplifier for the amplification of these errors. So for the amplification of these errors and getting the amplitude, we are sending it to the amplifier. There also we get these carriers as the modulated carriers. So the modulated carriers are like the finished points carrier, that is the straight edge point which is not soft. So you can see it in the picture also. These are very sharp edged points, and then it gets to the demodulator. Then it gets to the demodulated element in which these modulated carriers are converted to the demodulated carriers. So these demodulated carriers are sent to the filtered, so in which the filter gets the filtered waveform. So this is the filtered waveforms of the demodulated carriers, and then it is recorded in the meter. So the digital reading can be recorded in this meter. On the other end of the demodulator, it gets to the recorder which is demodulated and smoothened carriers. So these demodulated and smoothened carriers are then directly recorded in the recorder. So this is the work done in the Taylor Hopson Calixer, in which it consists of a E-shaped stamping. So this E-shaped stamping is connected to the armature and the stylus, which is attached to the skid. Whenever the surface get irregularities, it is sent to the these armature points, and then it is sent to the E-shaped stamping, which is attached to the piston bridge. Then it is sent to the amplifier and then the demodulator to the errorified carriers, that is the modulated carriers, and then it is demodulated and sent to the filter, and other end is sent to the recorder for the demodulated and smoothed errors, and then it is filtered and sent to the meter. So there we get the reading here in the meter. We can identify the readings in the meter. So that is the working of the. So let's see the construction of the Taylor Hopson Calixer. So the measuring head of the instrument consists of a diamond stylus of about 0.002 mm tip radius. So that is very minute tip it was. That is a sharp edge, and skid or shoe which is drawn across the surface by means of a motorized driving unit. So this is drawn across by the surface by means of a motorized driving unit, and the arm carrying stylus forms an armature. So the arm which is carrying the stylus with a skid forms an armature which pivots about the center of the piece of E-shaped stamping. So this is fixed to the E-shaped stamping of the center piece, and on the two legs of the outer pole pieces, that is in the E-shaped stamping, there are coils carrying an AC current. So it consists of the coils which are carrying the AC current. These two coils with other two resistances form an oscillator. So these two coils with the other two resistances forms an oscillator. So these oscillator, you can see it in the picture. So this is the oscillator in which it comes from the E-shaped stamping. So this is the construction. And coming to the Working of the Taylor Hopson Calixer. As the armature is pivoted about the center leg, any movement of the stylus causes the air gap to vary and thus the amplitude of the original AC current flowing in the coils is modulated. So whenever we are getting this modulated air gap in the stylus on the E-shaped stamping coils, then we get the AC current flowing in the coils is modulated. So this can be modulated in the coils, and this is further demodulated so that the current now is directly proportional to the vertical displacement of the stylus only. So then it is directly proportional to the stylus. So this stylus forms the air gaps in the E-shaped stamping. This is further demodulated so that the current is directly proportional to the vertical displacement of the stylus, and the demodulated output is caused to operate a pen recorder to produce a permanent record, and the meter gives the numerical assessment directly. So this forms the numerical assessment of the demodulated output directly. So this is the working of the Taylor-Hopson Calixer. By this, I am ending these video lectures. So these are the direct measuring instruments of the surface finish. In the next class, we are going to see the comparators. So different types of comparators. Thank you.